Welcome to my YouTube channel. Today we'll be tackling the three-sum problem. Given an integer array nums, return all triplets nums I, nums j, nums k, such that the indices are not equal. This is to prevent repetition of the values, and the three values should add up to 0. An example here, if you're given this array, this will be the output. If you're told to this will be the output. When you take the array on the 0th index and the integer on the first index and the second index, you'll get a value of 0. And so that's the same when you take 0 plus 1 plus -1, which is be equal to 0. But that's repetition from the first, and that would be repetition. We're trying to avoid that repetition, so there's only two relevant tuples you can add, you can put together. That's the only valid answer. For this problem, you use the two-pointer approach. The two-pointer approach is when you're given an array or any linear data structure, let's say A, B, C, D, E, F. You allocate 2 pointers onto the array, which increases the efficiency twice instead of going through the array one by one using a for loop. We'll use the convergence technique. We'll allocate 2 pointers at the beginning and at the end of the array, and then they'll check the array all converging towards each other. So we sort the input array, which helps us duplicate triplets. We first of all sort the given array to help us avoid duplicate triplets, and it allows us to use the two-pointer technique effectively or efficiently. And then we allocate our empty array called result, which will update later on. So the main loop will be fixing one element at a time. This is the main loop, so we write code to skip duplicates for the first number. Then since we're using the two-pointer technique, we'll allocate the pointers the beginning to the end. So we'll allocate left, which will be equals to I plus 1. Since left will be coming from the left side going towards the right, so we'll be adding the index of the array, and then right will be coming from the right side to the left side checking. When left is less than right, obviously we expect the left index to be lesser than the right index, since we're beginning from the left side indexing an array moving towards the right. So when left less than right, let's call it total. This will be the variable to check this condition. Nums I plus nums j plus nums k is equals to 0. So total is equals to so then here we check if total is less than 0. So if total is less than 0, then this means we need a larger sum, so we move the left pointer to the right. We had sorted the array from small to large. That means we have to move to the right side looking for a larger array. We'll move the left to the right, and therefore we add. And if total is greater than 0, this means that the total is a larger number, so we have to move left towards the smaller numbers to find a smaller value, which will give us an equals of 0. So that means we subtract the right hand side index by 1. So yeah. And if total is equals to 0, we can just say else. If total is equals to 0, then we append the results array. So we'll append the results array, and then here we'll add some logic to skip duplicates again. uh, while left, so this is some logic to skip duplicates, so while left is less than right as it should, and is equals to the number to the next index, then we just skip it and then we move ahead, and while right, skip it. And since this is an iteration, we finalize by we move the indices by 1 to the left and move the indices by 1 to the right. And so finally we can return results. And let's just run it and see if it works. I think I have an error somewhere here. Oh, the variables. Let's run it again and see. What? Results. Wow. So yeah, it has met all the cases, and we solved it using the two-pointer method. Let's submit and let's see the efficiency of our code. So run time we've beat 74%, and in memory we've only beat 18%, but the runtime is impressive. So yeah, thanks for watching this video. Please do subscribe, leave a comment, share, like, and yeah, all that stuff.